7.2 is about the Pythagorean Theorem. The formula for the Pythagorean Theorem is a squared plus b squared is equal to c squared. The Pythagorean Theorem can only be applied to right triangles. In our right triangle, C will always be the hypotenuse. You can identify which side is the hypotenuse because it's always across from our right angle. In this picture, which side do you think has to be C? This is our side that will always be C because it's across from the right angle. The other two sides can be labeled with A or B. It does not matter which one you make A and which one you make B. Let's look at an example of the Pythagorean Theorem. We're trying to solve for x. We know two sides of our right triangle. Because we know two sides, we can use Pythagorean Theorem. A squared plus b squared is equal to c squared. X is across from our right angle, so x must get plugged in for c. Now we have 3 squared plus 4 squared is equal to x squared, which gives us 9 plus 16 is equal to x squared, which will equal 25 equals x squared. Now we still need to solve for x. What we have is x squared equals 25. What we want is what x is equal to. To undo this square, we have to take the square root of it. But whatever you do to one side in an equation, you have to do to both sides. Therefore, we're going to take the square root of both sides. On the right side, we're just left with our x now, and the square root of 25 is equal to 5. Let's try one more example with the Pythagorean Theorem. Okay. In this picture, we still know two sides of a right triangle, which means we can use the Pythagorean Theorem. We have a squared plus b squared is equal to c squared. This time 20 is across from our right angle, which means 20 is getting plugged in for c. On the other side, we can have x squared plus 15 squared. This gives us x squared plus 225 is equal to 400. The next thing I would want to do is subtract 225 from both sides. Which would give me, I didn't bring a calculator with me. Hold on. So this gives me 5. That's going to give me 7, 1. Let me double check that to make sure it's correct. Yeah, that should be right. So we get x squared is equal to 175. Our last step is going to be to take the square root of both sides. On the left side, that would leave us with just x, and then we would have x is equal to the square root of 175. This does not have a whole number solution, so we're going to leave it just like this. Now we're going to talk about how you can tell if something forms a right triangle or not. Suppose I just gave you 3 numbers. 6, 8, and 10. And I wanted you to tell me, can this form a right triangle? We can determine that by plugging it into the Pythagorean Theorem. So we would have a squared plus b squared is equal to c squared. If these 3 numbers work in the Pythagorean Theorem and the 2 sides equal each other, then we can say yes, it's possible that they could form a right triangle. But without a picture, how can we tell which number to plug in where? If you remember, C always has to be the hypotenuse. The hypotenuse is always going to be the longest side of your triangle. So remember, C will always be your biggest side. Out of these 3 numbers, which is our biggest? You should have circled 10, which means 10 is going to get plugged in for C. We plug in 6 squared plus 8 squared is equal to 10 squared. This gives us 36 plus 64 is equal to 100. Do the 2 sides equal each other? Yes. We have 100 is equal to 100. Check. Therefore, our conclusion would be yes, forms a right triangle. The other thing that we can do with the Pythagorean theorem is something called a Pythagorean triple. Pythagorean triples have 2 things that are true. First, it's 3 numbers that can form a right triangle, so it works in the Pythagorean theorem. But secondly, it also has to be all whole numbers, so no decimals or fractions. Let's write that down. The first thing that's true about a Pythagorean triple is it's 3 numbers that work in the Pythagorean theorem. The second thing that's true is it's all whole numbers. Again, that means no decimals or fractions. Let's look at an example of a Pythagorean triple. The first thing that we want to say, that we want to look at if we're determining whether or not this is a Pythagorean triple, is do we have all whole numbers? So, yep, check. Yes, all whole numbers. Check. Now we need to check, does it work in the Pythagorean theorem? Okay. Again, how do we figure out which number to plug in where? Which number has to be C? You should have said 25 because it's our biggest number. 24 and 7 can get plugged in for either A or B. That doesn't make a difference where you plug those in. So we'll have 24 squared plus 7 squared is equal to 25 squared. 24 squared is equal to 576. 7 squared is 49. And 25 squared is 625. Do the two sides equal each other? Yes, they do. We have 625 is equal to 625. Check. So we can say yes, the Pythagorean triple. Okay. To recap, to determine if something forms a right triangle, you're only plugging it in to the Pythagorean theorem and checking to see do the two sides equal each other. If you also are checking for a Pythagorean triple, you have to make sure that you also have all whole numbers. Let's look at one more example where we have a right triangle but not a Pythagorean triple. Okay, here are three numbers. So right away we would notice that they're all fractions. Because they're all fractions, that would mean that they are not a Pythagorean triple. So they can't be a triple. But I still want to know, can they form a right triangle? To figure out if they can form a right triangle, we're going to plug them into the Pythagorean theorem. A squared plus B squared is equal to C squared. We will need to determine which of these is going to be our biggest fraction to figure out which one gets plugged in for C. To figure that out, you could put them into your calculator and get all of the decimals. If you did that, you would find out that 5/9 is the biggest number. When we plug everything else in, it would look like 4/9 squared plus 1/3 squared is equal to 5/9 squared. Simplifying this, when you square a fraction, you have to square both the top number and the bottom number. So we would get 16 over 81 plus 1 over 9 is equal to 25 over 81. We have another problem. We have 81 on the bottom here and 9 on the bottom here. We can't add fractions if the denominator is not the same, which means I need to find a common denominator. Our common denominator in this case is going to be 81. Therefore, we can leave this fraction alone, but I need to change 1/9 into, oops, I wrote that backwards. Sorry. That's supposed to be 81. I need to change 9 into 81st. 9 times what would give you 81? 9 times 9. So if I'm doing 9 times 9 to get 81 on the bottom, I also need to multiply my top number by 9. So I'm going to do 1 times 9, and that would give me 9. Now we can add our fractions because the denominators are the same. 16 plus 9 gives me 25. Denominator stays the same. So we end up with 25 over 81 is equal to 25 over 81. So check, they're equal to each other, which means yes, we have a right triangle.